So again, a lot of price elasticity can just be boiled down to this question. Which is bigger, the change in quantity or the change in price when we're comparing two situations? That's what we did here. All we did was we calculated that the change in quantity was 20% and the change in price was 60%. And we took the ratio of 2. So if the change in quantity is bigger, then the elasticity is going to be greater than 1 because, look, it's a ratio of these. It's there. The percentage change in quantity divided by the percentage change in price. So if the top number is bigger, that ratio is going to be greater than 1. The bottom number is bigger, the change in P, that ratio is going to be less than 1. And we say the curve's elastic. Remember, that's the flat curve. If the change in price is bigger, the number on the bottom is bigger, then the ratio is going to be less than 1. Our elasticity is less than 1. And we say the curve is inelastic, meaning it's the steep one. Again, it doesn't matter whether we're talking about supply or demand here. It works for both. If the two are equal, if the percentage change in quantity and the percentage change in price is equal, it's a very special curve or situation called a unitary elastic. I'll talk a bit later about what that means. Now again, remember, when we're doing all this, we're really only talking about a small area around where we're at. When we say the curve is elastic, we don't mean it's elastic for all of the curve. We just mean around the equilibrium where we are today. Market demand is elastic, meaning the curve is relatively flat. And if prices change by a little bit, quantity will change by a lot. That's all that we're saying. And, we're not saying anything about the top right or the bottom left. Okay. So one thing we can do is we can use price elasticity to find how much people are spending, right? Or total revenues. If you're the marketer, you want to know how much money your company's going to bring in with this new brand of toothpaste, you might be worried about the elasticity of demand, because that's going to tell you whether revenues will rise or fall if you change the price of your particular toothpaste. So here I've put the Lee family's 2 points up there again, right? $19.50 and they bought 18 kilos at a price of $10.50. So when prices fell by 60%, they only purchased 4 more, or around 20% quantity. So what happens if you look at, say, let's think about, say, moving from a price of $19.50 down to a price of $10.50. So price is about half. So in that case, another way of thinking about this is thinking about in terms of revenues. Maybe I should go to here. See if the camera's working. No, oh, that's dramatic. Lens caps off. Okay. All right, we won't do that bit of brilliance. Don't get to see my drawing. So revenues, right? Revenues are price times quantity. So if you're the people who are selling, or think about the other way, how much total money is the Lee family spending on fish? Well, at a price of $19.50 per kilo, and if they bought 18 fish, then the area would be the white area plus the blue area. That's the total amount, price times quantity. They bought 18 kilos of fish. Each kilo of fish costs them $19.50. So that whole rectangle is how much the Lee family is spending on fish. And that, in this case, it's $351 per year. What happens to the total amount of money the Lee family spends on fish per year if the price drops by half? Well, the answer is it depends what the price elasticity of demand is. That's where this comes into effect. The price almost halved, from $19.50 down to $10.50. Did the Lee family respond to that price fall by buying just a few more kilos of fish per year, or by buying a lot more? In this case, you can see, well, they only bought 4 more kilos of fish. So what happened? Well, in a sense, they saved the blue area because now the new spending on fish is the white area plus the red. So the net change in how much the Lee family spent per year on fish is the difference between blue and red. You can see in this case, the blue area is a lot bigger. So the Lee family should be spending less per year buying the total amounts of fish that they have after this change. And as you can see, the total spending is $231. So yeah, the Lee family is now spending $120 less per year on fish. Demand here is price inelastic. That's right. We calculated that the price, that the demand curve had a price elasticity of 0.33, which is less than 1. Can we do it here? Okay. Here's probably the easy way. This book has a really nice table in it. I like this one. So I shouldn't complain all the time about the book. But this is a nice little graph that basically summarizes the relationship between the calculated elasticity you'd arrive at and what guess you're going to have about revenues. So the Lee case is this bottom one. It says if the elasticity coefficient is less than 1, we calculated it to be a third. So it's less than 1. That means if the price falls, remember it fell from $19.50 down to $10.50, then the total spending, so the final column, will fall. Right? The Lee family spent $351 before the price changed at $19.50 per kilo. And when the price fell, the Lee family only spent $231. So that's that. You can see, if you looked at the reverse way, if we're thinking about that, in fact, the opposite happened. If the Lee family started off at 0.2, and at fish prices were $10.50 a kilo, but then fish prices almost doubled to $19.50 a kilo, then total spending's risen by 120 bucks. So if it's price inelastic, our elasticity coefficient is less than 1, and you can see that if prices fall, then spending falls. If prices rise, then spending rises. So the total spending of the family is the same as the price change, or it's in the same direction. But if we go to the other case where we're thinking about elastic, that's very flat demand curves. If the price falls, then the total spending will rise. Think about this case if the demand curve was very flat. If the demand curve is very flat, then this blue area is going to be very small because the price change isn't very much. But the red area is going to be very big because the quantity change is going to be large. So the family is going to spend a lot more money after the price falls. Think again, go back to here. We've got a very elastic demand curve, so the one in the upper left. If that demand curve is very elastic, a small drop in price will lead to a large increase in amount of fish, say, the Lee family will buy. That's going to mean that revenues actually will rise with the price fall. Oops. And the table. And if you have a very elastic demand curve and the price rises again, consumers buy a lot less of your good, the total spending on your. So for elastic curves, spending goes in the opposite direction to the price change.